All right, hi everyone, how are you doing? My name is Lucy Kerner. I work on security across the portfolio, do technical evangelism and technical marketing, go-to-market strategy. And I've been at Red Hat a little over 4 years. Spent the first 3 years of it actually as a senior solutions architect for senior cloud solutions architect in U.S. Government, supporting U.S. government customers.
Hey everyone, my name is Mark Thacker. I'm the Principal Technical Product Manager for Red Hat Enterprise Linux Security. I've been with Red Hat for 2+ years and with a security background prior to coming to Red Hat.
All right, so what we want to talk about today is we'll kind of first start out with what are some challenges with, when customers are adapting hybrid cloud, what are some security challenges that that you guys might face? And how can Red Hat help in terms of those types of security challenges with hybrid cloud? What is our definition of Red Hat Open Hybrid Cloud, and how does it apply across our cloud portfolio? So this is kind of our strategy and what we're going to talk about. So first disclaimer that this is the obligatory disclaimer for roadmap that this doesn't constitute in any way a binding or legal agreement. This is for discussion informational purposes only, and information we share is going to potentially change. And some of the product type roadmap topics, we're going to kind of touch it more from a across portfolios perspective versus go very deep into one product. So for example, if you wanted to have like a full OpenShift roadmap talk, you'd want to go to a OpenShift. We're going to focus mainly just on the hybrid cloud security aspects of those products. So some of the challenges that maybe some of you are facing as it relates to hybrid cloud might be things like, well, I'm introducing public cloud. I'm starting to introduce maybe my own private cloud like OpenStack. And now I'm starting to introduce containers. I'm starting to lose this visibility, this control over that infrastructure. All this complexity as it grows, this is introducing risk to my environment. I'm starting to now face governance and compliance challenges. The rules that I have in place, the policies that I have in place for my physical machines and my virtual machines, can I apply it when I go to containers? Can I apply it when I go to public cloud? And how does that affect me? Data security and privacy, supply chain security. When you start to introduce new vendors, maybe third-party public cloud providers, how does that affect what your supply chain and the security that you're trying to maintain there? So specifically, how would we help with hybrid cloud security challenges? So in terms of a management portfolio, our management portfolio can help with the first aspect, which is that visibility and that control over all of these separate, disparate environments. Compliance and governance challenges, we're going to talk about what are some of the tools that you can use to help with compliance and governance challenges for not just RHEL systems, but across your environment, whether it's virtual machines in VMware or containers in OpenShift, et cetera, and do it in an automated way. Data security and privacy, we're going to talk about that, and what are some benefits that you can get from our base operating system and in the inherited security from there to our layered products such as virtualization products, container products, et cetera. And then supply chain security in terms of we know how to make open source enterprise ready. What does that mean? What do we do to make RHEL what it is? And how is it different from upstream Linux? And what are we doing differently to bring that supply chain security into our software? How we think about security at Red Hat is we believe that security has to be continuous, that it has to be thought throughout the life cycle. And this is very similar diagram that you may see to the IT adaptive architecture that Gartner talks about, or the NIST cybersecurity framework. We think about security, it's the same way across our products. So for example, you want to design your security controls in from the beginning. An example inside Red Hat would be maybe you want to use Red Hat Consulting Services or our innovation labs or our security guides. You want to build security into your application. So our middleware portfolio has a lot of security built into tools to help you build security into the application. And also our container platform has built-in security features that allow you to build security into your application lifecycle and also the platform itself. You want to run on a secure platform. Of course, Red Hat Enterprise Linux, everything starts there. And then the layered products on top of that gets the benefits that RHEL brings when you install those products on top of RHEL. Manage is all about managing your hybrid environment and automating that environment, and this is where our management portfolio is mentioned, and this is where that shines. And Adapt is all about Red Hat Insights, Red Hat Security Advisories in terms of getting that proactive security information, deciding what to do based on that information you get, and not only information, but actual remediation Ansible playbooks that you get from problems that are discovered in your environment. So this is, again, another way to look at it and how our portfolio fits in nicely to this continuous security, continuous monitoring way that we think about security at Red Hat. Because we're not a security company like vendors out there that just focus on security products. We don't have a SKU for a security product. However, we have, as you'll see throughout this talk, we have security built into our products, and we think about security throughout our life cycle. When we think about hybrid cloud or open hybrid cloud at Red Hat, it's about these three different types of, these Olympic circles as you see here. So first of all is we give you the infrastructure to build your hybrid cloud on top of. I mentioned RHEL. We have layered products on top of Red Hat Enterprise Linux. Virtualization, OpenStack for private cloud. We also have storage, software-defined storage. We also have container-based platform. And then our container-native apps that allows you to span across all your 4 footprints, whether it's physical, virtual, private, and public cloud. And then what this allows is our hybrid cloud infrastructure and our cloud-native app platform allows you to abstract away the cloud underneath, right? So it doesn't matter that you don't have to have an expert in Amazon and an expert in Azure and an expert in OpenStack, right? We help you abstract that away with something like maybe you want to run have containers as the underlying infrastructure, but you don't want to worry about, well, how I'm going to run this in Amazon. Amazon has their own way of doing containers, and then Azure has their own way of doing containers. Something like OpenShift can do is abstract away that type of underlying infrastructure so that you have every person in your staff has the same skill set, that you don't have to have specialists in different areas. And then management and automation is about managing and automating that hybrid operate your data center, your infrastructure environment. And then integrated at the core is RHEL, and this is how RHEL is that stable, that technology that glues everything together, and that spans across the 4 footprints that I talked about, the traditional physical servers, virtual, private, and public cloud. And then the application is taking advantage of this new infrastructure, not having to worry about all the details in terms of the different types of cloud environments that may be underneath. Mark.
All right, thanks, Lucy. So what I'm going to do is I'm going to talk a little bit about the first of the 3 pillars, which is all about hybrid cloud infrastructure. And in this space, we're going to be talking about Red Hat Enterprise Linux, our Red Hat virtualization technologies, OpenStack, and OpenShift, kind of where we are today with the security in those products and where we're headed in the future. So again, as Lucy had alluded to, RHEL is at the core of everything that we do. This is the solid foundation upon which all of the rest of the Red Hat product portfolio is built. And it is that basis in which we can worry about, as a vendor, creating the strong infrastructure, right? Creating things like SE Linux, which we'll talk about in a little bit, that then all of the rest of the product you can benefit from. It also means that any innovation that we drive in the platform generally is automatically inherited up the stack. Modular some differences. Real quickly on what these products are, obviously Red Hat Enterprise Linux is our operating system. It runs across multiple platforms. In fact, if you saw the keynote, you saw it running on a Power 9, an IBM Power 9 system this morning. Runs on System 390, the mainframes. It also runs on ARM and, of course, x86. Imagine that, right? So it is the same Linux everywhere you go. From Red Hat Enterprise Linux, we move up into the virtualization space. And Red Hat Virtualization is our product that provides a virtualized platform built upon QEMU KVM. This then actually serves as the basis for our OpenStack platform, which is a private cloud solution that uses and leverages QEMU KVM as part of its virtualization strategy. And of course, you cannot forget about OpenShift, which is our container and Kubernetes runtime environment. And all of that is needing some place to store its data. That's where our Red Hat storage products fit in. We have two primary products in that space, which is our Gluster file system and our Ceph file system, right? And finally, we offer a bundle called Red Hat Cloud Infrastructure, which combines many of these products together. So enough of that. Let's talk a little bit about things that make Red Hat unique, and from a roadmap perspective, are going to be interesting. But I do want to touch upon Red Hat's supply chain security. This is one of the things that makes Red Hat different as a company. Let's be honest, there are a lot of packages out there in the open source community. And anyone, you could today go home and make your own Linux distribution. You could make your own container distribution if you want to. Just go grab some stuff, put it out. Anyway, people do this. It happens all the time. But what makes Red Hat unique is that we're fairly picky. We take leadership roles in the communities, like in particular cryptography and security. We have a great leadership role in many of the upstream communities in that space. But then we're also very picky about what packages we choose to include into our products. We do both manual and automatic code inspection on those. We don't just accept things from the upstream. Even our own upstream. Anyone here know what Fedora is? A couple of people? Yes, good, thank you. It's early in the morning, I get that. Fedora is the upstream, right? It's the incubation lab for everything that eventually winds up in Red Hat Enterprise Linux. Yet, I can tell you, we don't just simply take the packages out of Fedora and drop them into RHEL and call it enterprise grade, right? We're very picky about what we choose to do. We have our own build root environment. You can trust what we're building because we can rebuild it at any time consistently, right? It's not a one-time build on some developer's laptop. We have our own QA process, and then something that I've spent a lot of time working on is certifications, be that common criteria or FIPS. If anyone here touches a government agency at all, you will know about common criteria and FIPS. These are notoriously difficult certification procedures to go through. And imagine taking an open source product, which you don't control the entire development of, that's the beauty of it, and doing things like code inspection and actual inspection of the environment in which the developers work. We do that. We do that in order to get the certifications necessary to support you as a customer. Of course, we digitally sign everything. We have a secure distribution channel, and we provide the support and the security. In fact, later on Thursday, you'll be hearing a little bit about Spectre and Meltdown and how all that played out. It's all in the agenda. Well, as a good example of Red Hat's commitment to you and part of our kind of reverse roadmap, if you will, take a look at RHEL 5. Right? That's an old Linux kernel version, right? 2.x. Do you know who in the community developed the patches for Spectre and Meltdown for that? Oh, wait, it was Red Hat. No one else did it, right? That's part of our commitment about our secure supply chain. I want to spend a couple of minutes here talking about Red Hat Enterprise Linux. Like I said, it is the basis. Somewhat skewed due to the fact that I'm talking about it that we're going to spend more time here. I'm not going to go through every one of these features, but I do want to hit a few that are very important from a hybrid cloud perspective. Actually, the first I want to talk about is SE Linux, right? Security Enhanced Linux. This is the mandatory access control technology that provides the basis for separating processes, data, and file on a system from each other. Discretionary access control, I'm sure you know, right, is when I can give you access to anything that I want you to have access to. Mandatory access control steps in and says, yes, but there's a policy that prevents Mark from accessing Lucy's files on the system no matter what they try to do. In the case of hybrid cloud, the basis of how containers work and virtual machines work is SE Linux. If any of you know Dan Walsh, one of his more famous quotes is, "Containers don't contain." What does that mean, Dan? You're not following the marketing message. Well, what he really means is that containers are a great way to isolate workloads or provide a description of what workloads should be. But the thing that actually separates one workload from another is SE Linux mandatory access control. So if you're running containers, you're running SE Linux. You don't think about it. It's turned on. We have a default policy, but it's absolutely there. I want to talk also about OpenSCAP. As you're going to see at the end of this presentation, we're going to be talking a lot about how do you automate compliance. Well, we actually ship in Red Hat Enterprise Linux today something known as OpenSCAP. It is a scanner tool. It is also a compliance tool. Using OpenSCAP, you can scan your systems to ensure that they are up to date with the most recent patches for various CVE. You can also, most importantly, apply remediations to build your system up to a security baseline, right? So for example, if you're in a financial industry, you may have to deal with PCI DSS. So we actually ship and create a profile for OpenSCAP that allows you to more easily apply the security controls that work for PCI DSS across your entire enterprise. So what Lucy will be hitting on in just a little bit is where we're headed with OpenSCAP and security compliance. But this is the basis of how we can orchestrate and remediate security compliance across the entire enterprise. I also want to talk a little bit about system roles. So one of the things that we've started to do in Red Hat is, especially post-acquisition of Ansible, is we've started to create these system roles. One of the things our customers are telling us is, I want to be able to manage my RHEL 6, my RHEL 7, my future RHELs exactly the same way at scale across my enterprise, hybrid cloud and private cloud. That's what system roles are really good at. System roles allow us to define an Ansible playbook for managing an aspect of the operating system so that you, as an administrator of the system, only consume and use that Ansible playbook. You don't really actually care how SE Linux roles, for example, or SE Linux policies are applied to a system. You have a system role written in Ansible that will take care of that for you. Because how you apply, say, SE Linux policy is different in 6 than it is in 7, than it might be in the future. But through system roles, your way of administrating it is exactly the same. Clearly, this scales quite well when you use Ansible. Last thing I want to touch on before we move on is network-bound disk encryption. As I talk to customers, one of the things that they tell me is, well, I don't really use disk encryption today. Either one, I rely on my array vendor to do it, or two, you know, it's really painful. If I encrypt my disk and at 2 a.m. my system reboots, who's going to type in the password to unlock it, right? So we've actually solved that problem for you in RHEL. We started this in RHEL 7.4 and continued it in 7.5. If you are in a secured environment, we have the ability for you to encrypt your volumes, be they physical volumes, virtual volumes, whatever, and automatically unlock those volumes at boot time without any user intervention. Now, if that system or that drive leaves that secured environment, no more automatic unlocking. Now, the nice part about this is it doesn't require a complicated public key infrastructure at all. It's super stateless and highly scalable. Tens of thousands of transactions per second are possible with network-bound disk encryption. So this is a great technology. It allows you to then encrypt your data at rest across your hybrid cloud. Next 2 slides, we're going to be talking about technologies that we have today and where we're headed in the future with those technologies. Right, so I've already touched over on the left with the foundation of RHEL, SE Linux, we talked about common criteria, we talked about data at rest, right? Network-bound disk encryption, which is our policy-based encryption technology. The other thing that we provide in RHEL, which you will see inherited up the stack, is IPsec and SSL or TLS encryption, right? We provide those core foundation crypto libraries and functionalities that are used by OpenStack and OpenShift to encrypt communications between your workloads. And we've integrated user identity management right into RHEL. There's not a separate identity management SKU that you buy from us. It's integrated right into RHEL. That's what we have today, but this says roadmap, so where are we headed in the future, right? All right, so one of the things that we're investing in and looking strongly at is a system-wide crypto policy. Now, what this will allow us to do is ship a system and you, as a customer, be able to customize which cryptographic algorithms or protocols you want to have enabled or disabled on the box, right? So a bad example, but it's a good one that is easy to recognize. No one should be using DES anymore. If you raise your hand, oh, I'm using DES, then no, you've been hacked. Just, you don't know it yet. But using the system-wide crypto policy, you could disable a protocol like DES or whatever the future versions of DES might be that become easily broken. Turn it off, and every product on your system that's using the standard crypto frameworks provided in RHEL automatically lose the ability to use that crypto algorithm. The other thing that's going to make this interesting, quantum computing, right? quantum computing is going to be a very interesting way that people will be able to use quantum computers to break the keys of existing crypto technology. It's quite scary, actually. So we have, in the crypto policy, one of the things that we're working on is the ability to turn on a future-proof mode, where key lengths become longer, the crypto algorithms that you use become harder to crack, and it just applies across the board, right? And then OpenShift, OpenStack, they all inherit this automatically. All right. A couple of things I want to hit on here. I don't want to read every single one of these. Secure enclave protections. So we will enable new hardware technology from Intel, AMD, and possibly ARM. So Intel has something called Software Guard Extensions, SGX. AMD has their own secure encrypted virtualization, SEV, and ARM has something called trust zones. And we are looking at enabling that in RHEL so that workloads, be they containers or virtual machines, can have their own encrypted space in which to execute. This is an ideal use case for storing secrets, crypto keys, crypto algorithms, that kind of private information. That encrypted space, the host operating system cannot see into that, has no visibility into it, because the chip itself carves out a portion of the chip and says, okay, that execution, that portion of memory is tied to an enclave, and in that enclave, the following applications are running. It's not a separate operating system. It's a carved-off memory space that's encrypted. So you can see that's going to be really interesting when you get into the public cloud space, because now you can run some more sensitive workloads, or at least have more assurity that they're separated. This ties a little bit into broader HSM, or hardware security module support. Going forward, look for us to be investing more heavily in external HSMs, HSM devices that you put inside your systems, or trusted platform modules. Again, the big advantage being these are tamper-proof devices, right? When we are going to invest in that space, we want to make the use of this hardware transparent to you and very easy. It does you no good to have to write a custom application to use a hardware security module. We should actually enable that to work with our crypto policy that we're working on, for example. And things like OpenShift should just inherit the support of HSM. Same thing with OpenStack. And compliance everywhere. So look for us to expand the number of security compliance profiles that apply to RHEL, update them. Things like PCI DSS, as new versions of that come out, DISA STIG if you're into the DISA world, FedRAMP Moderate if you're interested in public cloud computing from a public sector point of view. So that's RHEL. And then I want to touch on this next slide. I'm going to hand it back over to Lucy. What about the virtualization side? Again, you've got RHEL, you've got your virtualization, you have OpenStack, and then OpenShift runs on top of all of that as well. So at the core of it, today our Red Hat virtualization and OpenStack products actually still use and will continue to use SE Linux, an SVIRT policy to provide secure separation of those workloads. We talked about that. They have secure multi-tenant administration. They use role-based access control. They tie that in with our identity management products today. The IPsec and the TLS capabilities I mentioned earlier are automatically integrated to provide peer-to-peer encrypted communication on our virtualization and our OpenStack products today. Again, leveraging what they have in RHEL. And you're already seeing the ability for you to deploy virtual machines that are pre-hardened according to a security compliance policy that you create or you consume from us or from the open source community. So where are we going? As you might guess, compliance guides, right? Things like FedRAMP. That's going to be a big deal for certain customers. We want to know, how can we make your life easier by creating additional security hardening guidelines that we help you automate? And Lucy will touch a little bit on automation in just a bit. I mentioned trusted platform modules and hardware security modules. So one area that we're really looking at is measured boot. Now, if you are running, for example, a Windows environment with a trusted platform module, this is something that's already built in if you're using BitLocker, right? It has a measured boot capability. We want to make that measured boot capability work at a broad scale, especially at the OpenStack scale. We're talking data center-wide deployments. How do you ensure that every time a virtual machine comes up and the OpenStack environment comes up, that it hasn't been changed, it hasn't been modified? You can store a signature in a hardware security module, measure the boot image as it comes up, and compare the two and decide whether or not you're going to pass. This goes beyond a UEFI secure boot. Also look for better identity management integration, especially identity management, which traditionally deals with Unix and Linux user IDs on a system, with our web-based single sign-on technology so that these two things become closer together, so that your application user ID is controlled by the same technology as the core underlying Linux user IDs. We have some of that today. We're going to continue to integrate and move on. I mentioned secure enclaves. That's exactly where encrypted virtual machines are going to come. You can look in the upstream community to see where we are in that process right now. To be honest with you, AMD with secure encrypted virtualization is a little bit further ahead, and so you look for that to probably land a little bit sooner, because that's something that's already in the upstream community. But again, you would be able to, in the future, use our OpenStack or our Red Hat virtualization product and declare that a virtual machine is fully encrypted, so that that virtual machine, its memory segments, everything that it does is completely isolated, even from the host virtual machine, or even from the host itself, from the host OS itself. All right, so this has given you a brief look at where we are today, what we do from a secure supply chain perspective, and where we're headed in the future. I'm going to turn it back over to Lucy to take you through the rest.
All right, so let's continue going up the stack. So the cloud-native app platform, of course, what we're going to highlight there is OpenShift. OpenShift has security built in from, as I said, the product itself has security features built in. That's what Defend is in terms of security features built into OpenShift, but also OpenShift runs on top of RHEL. So you get the security benefits from RHEL. Mark talked about FIPS, right? And that's actually a legal requirement in the US government, verifying cryptographic modules. And so if you care about sensitive data, this is something that that's why the US government mandates it across their infrastructure. We actually worked very closely with NIST to inherit FIPS, and we have wording on the NIST website that if you run, if OpenShift runs on top of RHEL, it inherits the FIPS certifications. So Defend is about security of the OpenShift and also security benefits you get from running on top of RHEL. Control is all about the security features inside OpenShift that helps with the application lifecycle. Things like having a container registry, getting content from a trusted source. Features such as allowing you to build in security gates with your CI/CD pipeline, and the features we have that helps you with that. Things like security context constraints and things that you can put into your deployment to help with security. Extend is all about extending the security features of OpenShift with partner technology, such as maybe for scanning you want to use Black Duck or Sonatype, or for networking, there's other networking partners that you may work with as well. So that's the high-level idea in terms of what's kind of already inside OpenShift. So similar to Mark, if we kind of look at the today and tomorrow, as Mark said, there are security technologies inside OpenShift to help you with providing that isolation at the base OS level. So things like SC Linux, things like namespaces, things like containers cannot run as root by default in OpenShift. SC Linux is on by default. You can't actually turn it off in OpenShift, but it's abstracted away from the developer. The developer doesn't actually have to worry about turning it on and turning it off and things like that. Also, auditing of access events. We have auditing capability. Compliance at build time. So into the build pipeline, you can actually build in compliance. We have the ability to, there's a scanner that we talked about, OpenSCAP, the scanner that you can use to scan your container images to look for vulnerabilities. We have a verified container catalog and also a container health index to tell you the grade of the container, how long has it been since it's last been updated, that kind of thing. So where we're going kind of in the future, things like common logging, things like a stronger secrets management, better integration with third-party products. We're looking at also for OpenShift compliance guys, as Mark mentioned, for our other products. Well, we're talking to some partners such as Aquasec about, okay, well, there are plugins to help make OpenShift Center for Internet Security compliant, right? can we work with these partners? How do we work with these partners? Should we be building in that technology itself at OpenShift, or should we be leveraging partners? These kinds of active discussions are happening. What about coming up with an OpenSCAP profile to lock down OpenShift? Those kinds of considerations are also kind of being considered. FIPS crypto validation for OpenShift itself, pervasive digital signing. And then, again, there's a vast partner ecosystem as we're looking into making that integration stronger and coming up with reference architectures to support that. Now, moving on to the management, now at the final layer, top of the stack, this is about our management portfolio. How can our management portfolio help with security and hybrid cloud security? So this is the nirvana picture that I'm going to paint, and that what you actually can achieve with our management products. And I'm not just kind of fluffing it, because there's actually a lab that I'm delivering tomorrow. It's repeated twice, where you can actually see all of this. So, number one, centralized management of your entire infrastructure. I don't care if it's virtual machines. I don't care if it's Windows, Linux. I don't care if it's public cloud, private cloud. Maybe you have a third-party ticketing system. A centralized way to see everything. When you look at the Cloud Security Alliance papers by them and things like that, they talk about this visibility and this control as one of the big challenges of hybrid cloud. You can't control what you can't see. Everything as code, infrastructure as code, and security as code. Why? Because that's going to give you that ability to repeat, that ability to share, verify, and then you can do audits much easier. Somebody left your company, okay, that doesn't matter. It's on GitHub, there are change logs there. You can track everything. And you want to use a consistent language. You want to make it easy to pass security audits. If those admins out there, what do the security people want? They're harassing you to give me a report of this, show me what's in this machine, all this stuff, right? You want to have controlled visibility into the state of compliance systems for the security audit. What I mean by that is, do I want to spend my time as an admin to tell you, the security guy, what are in these machines and what's installed and all this stuff? Or why don't I just give you limited access without root access? I'm just going to give you the ability to see what's inside without root access. Those kinds of things. So that way, you want to see which machines are vulnerable to Meltdown and Spectre, you go with your limited access account and you go see it for yourself. You run the report yourself, right? This is what I mean. Less back and forth between the operations and the security teams. You want to, from the birth of the machine, have a security compliant host. It's locked down to OpenSCAP's PCI DSS profile. We talked about OpenSCAP and RHEL 7.5. We ship Ansible playbooks that lock you down to these profiles, which means now you can create a security compliant host. You can create it from many different ways. You can create it from RHEL itself. You can create it from Ansible. You can create it Ansible tying in with our management products. You can create it from satellite, these lockdown hosts. You have that consistency now. You as the admins can decide what does a golden lockdown profile mean. You have that immutable OS. And then you want, after that, what do you want next? You want to have this continuous security. You want to have this continuous monitoring. This is all key in hybrid cloud. You also want to automate as much as possible, because once a human enters a data center, you are guaranteed error. So when your infrastructure gets even bigger, like when you introduce different technologies, you need to have automation in place. So the secret here is using OpenSCAP, which we talked about earlier, but also our management portfolio. So what's our management portfolio? Elevator pitch, Cloud Forms. This is our single pane of glass hybrid cloud manager. It can see into the environment. I can, down to the deep OS level, I can tell you what's in config files. I can tell you what's in etc SSHD config. I can tell you what's in it without any agents, and even though the machine is off. So I told you I was a cloud solution architect in the US government for 3 years. How the US government, some of the customers used it was, they said, okay, no machines can turn on unless I know what's inside every single of these machines. That's how they used it. So that way you have that visibility. You also have the ability to create reports. I talked to you about Meltdown and Spectre. I want to show me, I don't care if it's in VMware, I don't care if it's in Azure, I don't care if it's in Hyper-V. Show me everywhere where it is not under latest kernel. You know, if it's under, I think it was kernel 803 or 830 or something like that. If it's not that, then you know it's vulnerable. It could be vulnerable, right? So you want to tag all of that. You want to be notified of that. You want to set the ability to create control policies and the ability to create automation workflows. That's CloudForms. Ansible is our automation language. Why has it grown so fast? It's easy. It's YAML. It's not programming. It is something that if you know JSON, if you know XML, you can learn over a weekend. Not only that, we have modules and we have roles that are in modules that you can think of it as almost like libraries that you can call from a program. We have hundreds and hundreds of modules where you can reuse them. We also have hundreds and hundreds of roles where you can create playbooks from these already built roles. Oh, network, I'll just pull this Windows role, I'll pull this AWS role, whatever, and then in a matter of an hour, you have this really robust playbook. Satellite is about managing our RHEL systems, everything from content management, subscription management, provisioning, config management. Insights is our SaaS offering. This is a product that we are beefing up, as you'll see. This is our SaaS offering that can tell you not only security issues, it can tell you performance issues, config issues, and this is all based on knowledge that we have about your environment. This is custom information that we know about your environment. And not only are we telling you, we're giving you fixes. We're giving you Ansible playbooks that will say, okay, run this playbook, and you'll fix those issues. In the future, you'll see it actually beefing up even more, where it's getting information that I told you CloudForms is able to collect all this data. Why not get that information, pass it to Insights, those kinds of things. So there's a lot of growth in that Insights product. If you saw the keynote, Paul Cormier's keynote, he showed some of this vision that we have for Insights. So management automation focus areas. So today, we have our management product as an on-premise appliance. We're looking into some of that capability as a service, manage as a service, right? Management as a service, platform management as a service. Why? Because then we can, the public cloud providers are coming up with technologies really, really fast, right? Amazon. To keep up with that, it's a better idea if we had some of that management as a service as well. Self-service provisioning today is mostly IaaS, but why not have a self-service provision where you can literally provision anything, provision an app, provision networking, provision storage, whatever. We're looking at that as well. Today we can do governance reporting, but we also looking at compliance as a service. What does that mean? Well, things like, maybe I want to create a custom profile from the customer portal, or maybe I want to, these are kind of things we're kind of exploring, where how can I make it easy for a security auditor or officer to create custom profiles just right from a GUI kind of online GUI type of environment. Automated remediation, compliance security guides as well. Things like centralized auditing, things like better partner integrations. So I hope that kind of gave you guys an idea of how we are tackling hybrid cloud security at Red Hat in terms of across our portfolio perspective. So that visibility and control, as you saw, comes from our management portfolio. This is where that ability that we can help you, it lives. Compliance and governance challenges, this is all about using our automation tools, using things like OpenStack, using things like Ansible, using it in combat. When they work together, it's even more powerful. And this is kind of like what I talk about later today at 4, but also the lab tomorrow, and the repeated labs tomorrow. Data security and privacy that Mark talked about, and that's the supply chain security. There's a reason why we're leaders in Linux. There's things we do to make Linux secure. We know how to secure Linux, and that's what our supply chain security is all about. We have over 50+ sessions related to security at Summit. So some of the things we wanted to highlight here, I already talked about the automation portfolio and how that helps in terms of hybrid cloud security. There's also we talked about SCAP. I want to know how to create custom security profiles. There's a whole lab led by the developers of OpenSCAP. That's happening as well. Birds of a feather that I am doing in terms of security birds of a feather that I'm leading with Krob, who's a lead in product security. We're leading that. Security-oriented OpenShift within regulated environments. This is actually Santander talking about how they are running OpenShift in their regulated infrastructure and how they're doing that. There's also another similar type of panel type talk led by the US Navy. They're talking about disconnected OpenShift as well. Mark's doing a Red Hat security roadmap. Do you want to talk about that?
Yeah, sure. So in the Red Hat security roadmap on Thursday, we'll go through not just RHEL, but the rest of the product portfolio. And those today and tomorrow slides that you saw, we're going to try to do that for all of the products with a broad focus, not just on hybrid cloud security. We'll also have real-time discussion in there of the network-bound disk encryption that I mentioned earlier. With our IT office, can you imagine being IT for Red Hat, like internal IT, how much fun that must be? We're going to have them in to talk about how we're using network-bound disk encryption as a standard for how we're deploying our products here at Red Hat.
And then if you wanted to see a specific roadmap for some of our hybrid cloud infrastructure technologies like OpenStack, that's what that talk is, what's new in OpenStack. We have a data security and data privacy team. And that connecting the power of data security is what that talks about. If you visit the booth, you can actually see some of the technologies we talked about in demos in terms of automating security and compliance for hybrid cloud, and also RHEL security technologies that we talked about. There's demos of all of those as well at the booth.
And then before you leave this slide, two other things I want to highlight that maybe are not on the slide. Right outside on this floor, I saw Krob, our buddy, and our product security team, over in the consulting area, and he's doing live talks and demonstrations, fun game shows, talking about security vulnerabilities, what's happening in that space. So if you want to talk to the product security guys that are responsible for patching everything that we do at Red Hat, they are literally right out the doors here. The other thing I'd like to hit is if you have questions broadly about your Red Hat products and you want to do a deep dive, you want to talk to someone about a specific problem that you're having, on the show floor down the expo area, there is a booth dedicated to support. And our support staff is right there. They're not going to ask you what your contract number is, trust me. You can just go and talk to them, and they are brilliant. Those are the backline people that you would end up talking to on a conference call. So please go and visit them in there as well.
And if you wanted to talk about more specific things about roadmap or talk to product management or the Red Hat business unit people in general, that you can actually set appointments in the customer briefing center as well. So now it's time for your questions. It's also time after that to give us all 5s on the survey. And,
it's like Amazon, just give us all 5s, we'll like you better.
Yeah. And then I put profit there. I don't know if you guys know what I mean by that.
Big idea, stuff happens, profit. Yeah, we have actually some time to answer questions, and we can repeat them back so that they're on the recording as well. Any questions? Stunned silence? Yes. Okay, so the question was, visibility is great in the infrastructure. Do we have a plan about visibility into network traffic? So that's a good question. I wish Anita was here to answer that.
In the management portfolio, there is not deep visibility into the network traffic. Right now, it's actually being done by partner solutions. I haven't seen it in the roadmap, but that would be a good question to maybe talk to our management portfolio team about. But
and as an augment to that, in the Ansible space, in terms of managing the networking infrastructure, management of the networking appliances is a very fast-growing area, and our Ansible technology has great tools for doing that. That may not be the answer to your visibility question, but in terms of management, and back to what Lucy said, everything is code. Using Ansible, you can actually make all of your networking infrastructure completely describable as Ansible code.
Yeah, but if you're talking about like deep packet inspection and things like that, it's more partners.
That's more through our partners, right. But we do have significant plans in the area, and you can see this in the RHEL roadmap as well, around improvements for core networking technologies, the latest and greatest in TCP stacks, the latest fast data path. All of those are new technologies, but may not directly address your visibility question. Right. Question?
I'm not familiar with NVDE prior to this talk.
Okay.
What's the fundamental enabling mechanism that allows NVDE to work?
Sure. All right. Network-bound disk encryption. What's that fundamental enabling mechanism? So the answer is, come Thursday, I was just kidding. We actually will have the developer there during the presentation to talk about, but I'll give you my quick elevator pitch on what it is. Today with LUX, Linux Unified Keying System, which provides encrypted data at rest volumes. The issue is that you, as an administrator, type in a master password. That master password is stored on disk. And then at boot time, the boot system will ask you for that master password so that it can then pass it to the DRECUT system and continue with the rest of the boot. There are two technologies that are being delivered with network-bound disk encryption, or two daemons. Wrong word, not daemons. Two components, Clevis and Tang. Clevis is integrated with DRECUT, and Clevis is the client. And what Clevis does is that when you enroll a volume into Clevis, Clevis will take that key, re-encrypt it, and when it does the re-encryption, it uses the public key from the Tang server to do the encryption. And once it's encrypted, it throws away the public key. So that at boot time, when the system comes up, Clevis steps in and says, hey, look, I need to unencrypt this, but I don't have all the information I need. On purpose, it does not have what it needs to decrypt the volume. It then reaches out across the network to the Tang server and says, just give me your public key. You don't know anything about me because I'm completely stateless. Tang is stateless. Tang returns the public key. Those two match. Unencryption happens. The boot continues. The nice part about that is no PKI. The Tang server is completely stateless, so it doesn't have to know anything about your individual clients. And the only thing that's passed over the wire, other than an enrollment time, actually even an enrollment time period, the only thing that goes over the wire is a public key. You don't even have to encrypt the transaction. Which, if you think about it, is solving the chicken and egg problem, because at boot time, if you need to encrypt, but you need a key to encrypt, how do you, which is the failing of most PKI at boot time systems. This takes care of it completely. It works on boot volumes and data volumes at boot time as well. And you can use it for other purposes, and that's where we're headed, is other purposes.
And it's like one of the easiest things to set up. We do it in our RHEL security lab. It's about 4 steps, or something like that.
It's 4 steps, you're done, and it's an incredibly awesome, boring demo. What I mean by that is you boot the system, it says, password, oh wait, got it, and keeps going. And that's exactly what you want, is a hands-off. It's still encrypted and it's still volume, so you take that encrypted volume out, you can't use it anywhere else. So come on Thursday, we'll talk about some enhancements to that. Maybe using TPMs, maybe multi-tangs. DRECUT has to have a network stack up to work. Until we get to other things like maybe using those hardware security modules, which would be physically located on the system. I think we're about out of time at this point.
I have a question. Are you guys do you guys have a hybrid cloud, or are you guys just mainly like physical machines and virtual machines?
No, we're both.
What does a hand up mean? Like, that you guys are using public cloud and other types of OpenStack, things like that? Okay.
Okay. All right. Good to know.
All right. Well, thank you so much for your time, and find us if you guys have any other questions.
Thank you. Enjoy Summit.